Hi guys, Mr. Ayers here, and today we're going to look at the next lesson in this second topic of our linear relationships and functions unit. So today we're going to talk about specifically how to graph linear inequalities on the plane. We're going to start with this example right here on the screen. It's the first example that you'll see in the notes, and I'm going to have you guys pause the video, and I want you to graph this equation on the plane here on your notes, and then after you graph it yourself, you can check it out with my work, and we'll go from there. Okay, so go ahead and pause the video, and I'll see you on the other side. Okay, guys, so this one shouldn't have been that much trouble for you, I don't believe. You guys should remember that your slope is -2 over 1, and your intercept is 0, 3. So we're going to start at 0, 3 right here. We're going to go down 2 levels and 1 level to the right, put a point here at 1, 1, and then we'll connect our points together. And that's our line. That's how we graph a linear equation. Now the question becomes, how do we graph this relationship? Y is greater than or equal to -2x plus 3. I'm going to give you a few minutes to try some experimentation on this. So I want you to pause the video and just try a couple of things. And then I will once again see you on the other side with some more specific information. Okay, maybe the first thing that might be helpful is maybe we can just figure out what order pairs could possibly be solutions to this inequality. Maybe just do some testing and just see what works, because I don't think every possible order pair on the plane is going to be a solution. So let's take a look at an order pair. I'm going to pick the order pair 2, 1. So we're just going to test the point 2, 1. Okay? So that means I'm just going to let x equals 2 and y equals 1. And we're going to plug these values in and see if we get a true statement. So the question is 1 greater than -2 times 2 plus 3? And when you work the right side of this, you'll get 1 greater than or equal to -4 plus 3. And that becomes 1 is greater than or equal to -1. And that is a true statement. So then 2, 1 is a solution to this inequality. So I'm going to go ahead and put a point right there. Actually, you know what? I'm going to color that green so then we know it's a correct solution. So we're going to put that right there. Okay? And now let's pick another order pair. Let's pick, how about -2, 3? Okay? So let's test -2, 3. And we'll do the same work again. So we're going to do 3 greater than or equal to -2 times -2 plus 3. And we have 3 then less than or equal to 4 plus 3. That means we have 3 greater than or equal to 7. And I might have said less than or equal to in the last step. I apologize for that. But definitely 3 is not greater than or equal to 7. So this order pair is not a solution. So let's go ahead and plot that point on here. That was the point -2, 3. So that's going to be the point right here. So I'm coloring that one red. That's not a solution. And then why don't you test 2 more points real quickly, just on your own. It can be any 2 points you want, 2 order pairs, and then hit pause and test those 2 order pairs, and then come back, and I'll have 2 more on here that we'll look at and kind of form some conclusions here. So go ahead and pause, and I'll see you on the other side. Okay, so I thought what we would do is we would test maybe -3, 1, and let's test 4, 0. Why not? Okay, so from -3, 1, we have 1 greater than or equal to -2 times -3 plus 3, so 1 greater than or equal to 6 plus 3, 1 greater than or equal to 9. And that is, again, not true. So that's not going to be a solution. So negative 3, 1 is right there. And let's test 4, 0. So if we do 4, 0, we're trying to test to see if 0 is greater than or equal to negative 2 times 4 plus 3. So 0 greater than or equal to negative 8 plus 3, which becomes negative 5. That is true. So 4, 0 is right there. Now, notice something. What do you notice? What do you wonder about our ordered pairs here? Okay, I've noticed a couple of things here about them, but I want you to take a minute and notice some things. So just pause for just a quick moment and gather your thoughts, and then when you're ready to continue, I'm going to show you something really cool about this. Okay? I'll see you on the other side. Okay, if we go back here and put our equation from the last example up here, y equals negative 2x plus 1, we graph that line, then I want you to see what happens here. I'm going to go ahead and graph it again in blue, so it's going to be right here at 0, 3 again. 0, 3 is right here. And then down 2, right 1 is right there. I'll pop it back on here again for us, hopefully. There we go. Now I want you to notice something. The two solutions that worked, or the two ordered pairs that were solutions, are on the right side of this line, and the two solutions that didn't work are on the left side of this line. For an inequality, what happens is that the line that we graph, it was an equation, is called the boundary line. Okay, so y greater than or equal to negative 2x plus 3. If we change that to y equals negative 2x plus 3, okay, and I'm going to get rid of all this work that we did because we don't need to have it anymore, okay, then here's what happens. This becomes what we call a boundary line. And what it does is it divides our coordinate plane into two half planes, okay? So a half plane would be this area right here, and this plane right over here. They're both called half planes, okay? But only one of those two half planes is going to be the solution for this inequality. And I tend to call that the solution zone. So if you notice that all of the ordered pairs that worked were on the right side of this line. So the solution zone would be any ordered pair on the right side of that boundary line. So in order to represent that on the coordinate plane, then we would shade that half plane like so, all the way up to the boundary line, and everything in between here to represent the solution to this inequality. Because remember, inequalities have infinitely many solutions. So we need to represent that graphically. And there's my solution. Okay? So what I'm going to do over here on the left side where we put our work is I'm going to write just a little quick little step-by-step here for this, okay? So we're going to graph the boundary line, okay? And then we're going to have to do something else here. There's an easier way to figure this out every time. So then we don't have to go ahead and just test random ordered pairs all the time and hopefully get lucky. We're going to fine tune this process just a little bit in this first example that we're about to do. And hopefully that will help get the rest of this done a little bit more efficiently. So let me go to the next example here. We have y less than or equal to negative 1/3 x plus 2. Okay, so the very first thing we're going to do is we're going to graph y is equal to negative 1/3 x plus 2. So I want you guys to go ahead and graph that boundary line, and then I'll pause the video and graph that boundary line, and then I'll see you on the other side, and we'll double check and make sure you have the right boundary line on your coordinate plane, okay? So I'll see you on the other side. All right, well, your slope, as you know, is -1/3, and your y-intercept is 0, 2. So I'm going to start this graph at 0, 2, right there. I'm going to go down 1 level, 3 levels to the right, which is right there. All right, and then I'm going to connect them together. Now, the one thing about these boundary lines is that when you do an inequality boundary line, you want to make sure that your boundary line extends from one edge of the coordinate plane all the way to the other edge. It has to go through the entire plane because we want to make sure we are able to distinguish which side of that boundary line is the solution zone. Okay? So that's very, very important. So make sure you extend your boundary lines from one end to the other end. All right, so we have the boundary line, so we have to figure out if we're going to shade above or below the line. So what we're going to incorporate here in our process is called a point test, okay? And when we can, we're going to test the same point every single time so that then we're consistent in our work and then we have less room for error. Now, think about for just a second what might be one of the easiest ordered pairs to test to see if it's a solution or not. What would be the one that would give us the easiest numbers to work with? Okay? And I'm going to pause for a second, give you a chance to think about that, and then we're going to talk about what you thought and what might be the best thing to do on the other side. So I'll give you just a second. Okay, so I hope you guys thought about the point 0, 0, which is the origin, because that would actually be the easiest point to test. If both values are 0, then a lot of the terms will become 0, and it's easier to simplify and it's easier to compare. So when your boundary line does not pass through the point 0, 0, you can use 0, 0 as what we call a test point, okay, or a test ordered pair. If your boundary line does happen to pass through the point 0, 0, that's okay. Just pick something that's real close next to it, like 0, 1, or 1, 0, or something that's real easy still to use. So we're going to test 0, 0 into our inequality, and we're going to see if that makes the inequality true or if it makes it false. So remember, that means x equals 0 and y equals 0. I'm actually going to plot it right here so we know where it is. Okay, so there's where 0, 0 is. And we're just going to plug in the numbers. So the question becomes, is 0 less than or equal to -1/3 times 0 plus 2? Okay, and if you do the math, 0 less than or equal to -1/3 times 0 is 0. So we get 0 plus 2, and that becomes 2. And 0 is indeed less than or equal to 2. This is a true statement. That means 0, 0 is a solution. So if 0, 0 is a solution, by our investigation on the last example, we know now that all of these solutions to this inequality are below the boundary line. So we're just going to go ahead and represent that with this shading right here. And yes, you will have to graph and shade for these inequalities all the time and identify the solution zone. So there we go. Okay, and there is the answer to example 1. All right, we're going to go ahead and look at example 2 now. And I'm going to let you see what you can do with example 2 on your own. And then I'll give you pause the video, try it on your own, and then we'll touch base and talk about some of the interesting things about this example on the other side. So I'm going to let you pause, work it on your own, and then we'll look at it together after you resume the video. Okay, so here's the deal on this one. This one's in standard form, so we need to get it in a good graphing form, which is slope-intercept form. So the first thing that I'm going to do is solve this inequality for y, okay? So in order to do that, I'm going to subtract 3x from each side. So subtract 3x there and there. Those cancel out. I get 2y is greater than negative 3x plus 10. And then I'm going to divide every term by 2. I'm going to get y is greater than negative 3 halves x plus 5. So I'm going to graph the boundary line y is equal to negative 3 halves x plus 5. So my slope is negative 3 halves. My intercept is 0, 5. So I'm going to plot that point first. 2, 3, 4, 5. It's right up here. Down 3 levels. 1, 2, 3. Over 2 to the right. Gives me the point 2, 2 right there. Okay. Now, this is something a little more interesting here. Okay? Because I'm going to go ahead and graph my line. But then I want you to notice something about this one. This one's a little bit different. Because this symbol in my inequality is not an equal to symbol. It is only greater than. When that happens, you have to represent that with a different looking boundary line. Because before, like for example, in example 1, any ordered pair on the boundary line is a solution because it says y is less than or equal to. However, on example 2, since it's just greater than and there is no equal to, the boundary line is just that. It just acts as a boundary line, but is not part of the solution. So to indicate when the boundary line is not part of a solution, we use a dashed line. So we're just going to dash it like that. And then we know for sure that it's only just giving us the 2 half planes. So we have to figure out then which half plane is the solution. All right. Still test 0, 0 though, because that's a good point to test always. So we're going to test 0, 0 right here. And we're going to do that right down here. Okay, so we'll put it up here. So is 0 greater than negative 3 halves times 0 plus 5. And if you also wanted to test standard form, the 3x plus 2y greater than 10, you could test that as well. It doesn't matter, okay? Whichever one works best for you. So 0 greater than 0 plus 5. 0 is not greater than 5. That is not true. This is false. Okay? This is false. So 0, 0 is below the line. Since that was not a solution, now I know that the solutions are on the right side of the line or above the boundary line. So I'm going to represent that region by shading it. And remember, as you listen to me talk, if you miss anything or you need to hear something again, go back, rewind it, and do so, because sometimes I might talk too fast for some people. So don't be afraid to get it, to review it anytime you need to. There's example 2 for us. Okay? So basically all we have to do is graph the boundary line and then figure out what side of the boundary line to shade, what half plane. And then also sometimes you might have to solve the equation or the inequality for y before you start doing your work so you can get the correct equation of the boundary line. All right? And again, if you have any questions, just email me or whatever so I can help you out. All right? Let's take a look at example 3 now. All right, again, I want you to pause the video and see what you can do with example 3, and we'll discuss it on the other side. Good luck. Okay, so hopefully you solved the inequality for y. So we're going to start with that first. Okay, so I'm going to go ahead and add subtract my 3x from each side. Let me change it to my marker. There we go. So subtract 3x from each side, and then we have negative 4y is greater than negative 3x plus 12. Now we're going to divide by negative 4. Now, if you remember a rule about inequalities, you need to remember that whenever you multiply or divide by a negative number to get a variable by itself, you have to reverse the symbol. So I hope that when you did your work, you reverse the symbol in your final inequality. So it's y is less than 3/4 x minus 3. Okay? Those negative signs right there, they also cancel out. So make sure you cancel those out as well. All right? Go ahead and graph the boundary line. We're going to be at 0, -3. So 0, -3 is right here. 3 up for the right puts me at the point 4, 0, right there. Okay? And note the symbol. Is it going to be a solid line or a dashed line? That's really important. Okay, so there's my boundary line right there. I'm going to change it to a dashed line so it's not an equal to symbol. And we're in business. Okay, now, again, test the point 0, 0 right there. Okay, so if we're going to test 0, 0, then the question is 0 less than 3/4 times 0 minus 3? So go ahead and do the work for that. We get 0 less than -3, and again, 0 is not less than -3. This is false. Okay, so again, we're going to shade below and to the right of the boundary line. We're going to shade right here. This contains the solution. All right, so far, let's go back up to the top of the notes and finish our procedure now, okay? So number 1, graph the boundary line. I'll put a little note in here about solid and dashed lines. Solid if the symbol is less than or equal to, greater than or equal to. Dashed if it is less than or greater than. Okay, and then number 2, test an ordered pair. And I'm going to put 0, 0 up here, okay, as the one that we typically like to test. Let's do it like that. And shade the correct half plane. Okay, so there we go. Now, we have a few more examples to do here. So we're going to look at example 4. This is a special case, so it won't take you that long. We'll do this one together. For example, we should now know, after our discussion from the first part of this topic, that y equaling a number indicates a horizontal line. So basically what this is telling us is that our boundary line is a horizontal line. And so I'm going to go ahead and graph that line right through -3, because that means every y coordinate is -3, and it's solid, so I'm going to leave it as a solid line. Okay, I can still test if 0, 0 is a solution or not. So if 0, 0 is a solution, then the question is 0 greater than or equal to -3? And that is true. So I'm going to shade above my boundary line. I'm going to shade all this region or half plane above the line, just like so. Likewise, for graph number B, that's a vertical line through the point for every x coordinate being 4. So that's going to go through 4, 0. And it's also going to be dashed. So I'm going to graph it through the point 4, 0, going vertical. I'll move it over just a little bit. I'm going to do that one again. That was not so good. Let's try this one. Let's try the perfect. Okay, dash the line. And then again, we have to decide what side we shade. 0, 0 is right here. Okay, so the question becomes, is 0 less than 4? And again, this is a true statement. So I'm going to shade to the left side of this line to indicate that is the correct half plane. And when you're shading, you need to try to get everything. If you're using a pencil or whatever on your homework, or if you're doing this on your notes or whatever, we can talk about in person some different shading styles you can use. So you don't, if it's a big half plane, you might not have to shade it all up or whatever. You can put it maybe like a design in there or something. But we'll need to clear that first and discuss that in person. So we'll do that. Okay, so you've had several examples now of how to graph an linear inequality. Let's take a look at a couple of word problems to wrap up, and then we'll be in good shape for this lesson. So there is the word problem. I'm gonna let you read it and do part A. So we're gonna read it, and then we'll just write the inequality, and then we'll talk about graphing the inequality. Okay, so I'm gonna let you pause the video here, read it, mark your text, and then we will generate the inequality on the other side. Good luck. Okay, so let's mark some things here on this, okay? First of all, it says at most $12, so that's important to know. In fact, I'm going to highlight that in green because that's talking about how the inequality is set up. So what does that mean? At most is less than or equal to 12, okay? It says red peppers cost $4 per pound. If X is red peppers, pounds of red peppers, okay, then this is red peppers, then we need to make sure we have 4 times X in our inequality, okay? And then likewise, it says tomatoes cost $3 per pound. So, and Y is the number of pounds of tomatoes. So, when I'm going to set up my inequality here, okay, I'm going to write, then, I'm going to put it right up here. 4X plus 3Y is less than or equal to 12. Does that look right? Red peppers cost $4 per pound. Yep. Tomatoes cost $3 per pound. Yep. At most $12. That's the inequality. There's my graph. Okay. So I am going to solve this inequality for Y and then graph it. Why don't you go ahead and do that now and pause the video and do that now, and then after you do yours, you can check it with mine. So go ahead and solve this inequality for Y. Graph the inequality on the coordinate plane you see. Remember that it's just a quadrant 1 plane, and I will pick up this conversation after you have completed this on the other side. Okay, so I'm going to do subtraction of 4x on each side. So there and there. Cancel those out. I get 3y is less than negative 4x plus 12. Divide everything by a 3, a positive 3, which means I do not need to switch the symbol on this one. Okay. And my final graphing form is y is less than or equal to negative 4/3 x plus 4. All right, so over here on the graph, I know that my slope is negative 4/3. My y-intercept is 0, 4. So plot 0, 4 right there. Go down 4, right 3. That puts me right here. All right, I'm going to connect these together. It is a solid line, so I don't have to worry about that. Now I just need to figure out what side of that line to shade. Well, 0, 0 is still down here in the bottom left-hand corner. So I'm going to still use that as a point test here. So we're still going to test 0, 0. You might be able to do this test mentally. In fact, if you put it in standard form on this one, you probably should be able to do it mentally. We'll use standard form on this one. So we'll just say is 4 times 0 plus 3 times 0 less than or equal to 12. That's what we're checking, okay? And 0 plus 0 is less than or equal to 12. It is. 0 is less than or equal to 12. It checks, okay? So we know then 0, 0 is a solution. So then everything on this left side of this boundary line is a solution. The solution zone this time is going to be this little triangle right here, like so. Okay, so there's our graph. Now for part B, I'm zoom this out just a little bit so you can still see the graph. So for part B, it says interpret the x and y intercepts of the graph in regard to the context of the problem. Great. We can do that now because the x-intercept is 4, 0. Okay, so what's that mean? That means Tim can, and I made a mistake on this, it should be 3, 0, my mistake. Tim can spend or can purchase 3 pounds of peppers, right? And no pounds of tomatoes. So okay, and then likewise for the y-intercept, that's 0, 4. So then we can say, I'm just going to copy this and just change the numbers. We're going to say then that that didn't work like I wanted it to. Let's just go ahead and write it down again. Tim can purchase 4 pounds of tomatoes and 0 pounds peppers. All right, and I'm going to leave it there. There's one more word problem here that I want you guys to work on your own. Okay, it's this one right here with the drama club. And I want you guys to work this one just like you did the previous one. And we'll touch base in class on this one when we see each other again. So I hope that you have success with this. And if you need to talk to me about anything or whatever, send me an email. And I hope to see you guys soon. Thanks. Take care, guys.